Hello everyone, my name is Tom Liu, and today I'm going to be talking about pepper's role in pharmaceutics. So to start this off, I'd like to give a little background about pepper itself. Its scientific name is Piper nigrum, and the Dutch used to have a saying called pepper duur, which described an object which was as expensive as pepper. This phrase traces back to the golden ages of spice trade for them, but even today, pepper is still one of the most important and popular of all spices. There are two active ingredients found in pepper, which are piperin, which gives the pungent principle of pepper, and rotungent, which gives pepper its aroma. Many people know the culinary uses of pepper, as it is used in a variety of dishes ranging from strawberries to steak. But not many people know about its medicinal uses, where it is used to help treat bronchitis, malaria and cholera, and fight diabetes and cancer. But what I'm going to be focusing on is how pepper is able to increase the bioavailability of other drugs. Bioavailability is defined as the rate and extent to which the active ingredient or active moiety is absorbed from a drug product and becomes available at the site of action. This is important as it is essential to know how many available nutrients there are when supplements and other drugs are ingested. So I've already done some research in how piperin is able to be used, and I found an article by Jangra et al. Which describes how piperin is able to augment the protective effect of curcumin against lipopolysaccharide-induced neurobehavioral and neurochemical deficits in mice. These deficits in mice lower the brain-derived neurotrophic factor, which in turn causes anxiety and depression. What Jangra et al. Did was to take 8 groups of mice and pre-treat them with the control vehicle, which was just peanut oil, and then the experimental groups for 7 days. Afterwards, the mice were induced with the deficits and then tested for their anxiety with an elevated plus MACE test, an open field test, and light-dark box transitions. When comparing the control group with the pre-treated curcumin and piperin group and the elevated plus MACE test, it can be seen that with the pre-treated group, it closely resembles a control group, and this correlation is seen in other tests as well. So what this shows us is that even though curcumin and piperin can address some of the anxiety and depression of mice alone, the conjugation of both shows a more pronounced effect. Thus, it can be inferred that piperin is a bioavailability enhancer of curcumin. Knowing this, I was interested in how piperin was able to actually enhance the bioavailability, and I found another article by Patil et al. That described just that. What they did was to carry out high level quantum chemical calculations to derive new insights into the structure and binding of piperin, and they finally obtained an optimized geometry of piperin. As a result, they found that piperin is able to enhance curcumin's bioavailability by intercalating with it, and with that, it's able to transport curcumin. This combined with the fact that piperin has the tendency to bind to multiple sites of cytochrome P450 enzymes, which are essential for the metabolism of many medications, provide a basis for a dual mechanism and explain why piperin can enhance the bioavailability of curcumin. Continuing in this line of thought, I have found another article by Rajat et al. That describes a potential application of piperin in medicine, which is the conjugation of docetaxel with multi-walled carbon nanotubes and co-delivery with piperin. To give a little background on docetaxel, it is an indispensable anti-cancer agent that is used in various chemotherapies, yet it has major weaknesses that restrict its full potential, which are poor aqueous solubility, bioavailability, tissue permeability, and drug release moderation. The conjugate of docetaxel to a multi-walled carbon nanotube allows better drug release moderation and is more toxic to cancer cells. Additionally, when this conjugate is co-delivered with piperin, its performance was exceptionally improved, as demonstrated by the graphs. This means that it could be a beneficial option for performance enhancement on docetaxel and chemotherapy. After learning how piperin is able to increase the bioavailability of drugs, I felt as if I could somehow impact the subject, and here's how. As I said earlier, not that many people are aware of the medicinal uses of piperin, and one of the main factors of a project being essentially funded is largely determined by how much support it has. Thus, one of the impacts that I can make to this topic would be to ultimately spread awareness of this topic through everyone I meet. Additionally, increasing my knowledge base further from high school and first year college would help my own understanding of and then allow me to conduct or help a researcher on research upon the application of piperin. This concludes this video on how piperin is able to be used in pharmaceutics. I hope you enjoyed it.